Hey, what's up guys? On today's video, we are going to talk about functions. So we are gonna pretty much gonna cover everything about function on Go programming language. So we start with the function declaration. So to declare a function, bring the examples here. So we are gonna define a function with the func here, and with the function signature, we pass the param, we define the type, and we gonna define a return type. So if we're gonna call a function in main here, so we call a function and then we pass the value to the variable called result, so we are able to print that out. So let's say here, there we go. The result is quite straightforward. Say function and the function name, and passing the params and the return type. Okay. So, and then next move on to next recursion. So basically the function is the first class citizen in Go programming language, same as in JavaScript, and so it can be returned. It can be like assigned to a variable, and it can be passing as a param. So for a recursion here, get example here. That's a very common example, factorial, and so basically we have defined a function called factorial, and we have a base case that we're gonna return that. Otherwise, if that's not a base case, we're gonna times the function itself, and then we pass the params -1. So that basically is like this 5 times 4, 5 times 3, and it basically a function it call itself. So function it call itself and return different value, and it's like a recursion until it meet this condition, so it will return back. So that's going to be output of 120. As you can see, that's a result here. And let's move on to multiple return value. So in Go programming language, we don't use try and catch. Normally, like in I'm a front-end developer, so we normally use like try and catch to catch the error. But in Go programming language, we use the return value to check if there's to catch an error, or to check if there's like any like a not match condition. So we have an example here. We have a function called divide, and the divide that return two values. The first one is a value, second one is the error. So if that's the error can be like a nil, it means like it doesn't have error. Otherwise, we're gonna bring out we're gonna return the error message. So this function that always return two values. So we check the second value here. So we make sure that's there's not error. So in order we can continue with the program. So that's like very common way to deal with the error, and to check if the value from a function is legit. Okay. Another big thing we're gonna cover here is called error. As you can see, there's the program is like a Lego. We build on with the big project is built on with all different functions. like a lot of the function that build one project. So the function going to be combined. They're going to be combined together, but we need to make sure all functions that work properly. So if there's any error in a function, so we need to deal with that. So we have a different way. I think there's like 4, 5 different way to deal with error. So let's just give you an example. If there's the first strategy for deal with error is propagating error. So gonna give you a code example here. So for this example, so we have defined a function here called divide, and we called on this function main is a caller. So we call a function called divide. So if there's a problem, right? If there's an error, it's gonna return the error. It doesn't it doesn't terminate or it doesn't kill the program on this function. So it pass on the error. So stack caller is gonna deal with it. So as you can see, this is a main function. That's the subs function. We might have like multiple sub functions, but on the main function we need to deal with the problem. So the subs function, they only do is that if there's error, they're gonna pass the error to caller. So that's first one strategy, and there's second one strategy called logging and continue. So let me give you an example here. So for logging and continue, for example, we have a like read file. So if we reading the file, right, if for whatever reason there's an error, there's an error here. It might be like file is not existing, or the file is like it's not working anymore. So we're gonna print out the error and then we're gonna return that. So so we're gonna continue the program. Like this is the sub function, this is the main function. So on the main function we call a sub function. Also this is gonna cause a problem. That's gonna cause an error. So we're gonna leave it. And because this is just an example, because normally if you read a file, you need some information from file. Like for this, we can say like for instance, you can say like log, or maybe you're gonna get like get a log or whatever reason, right? So you're gonna call this log, even that log that's cause an error. It doesn't actually affect the main function. So we just leave it alone. We're gonna carry on with the main program. So this is that we get a log, we continue the program, so it doesn't stop or it doesn't terminate the program. That's the one of the strategy. That's only for something that's not affect the program. Okay, let's move on for next one called exit and exit the program. So got an example here. So we have we're gonna check error. So basically we open a file that for some reason there's an error. So if we need a data from this file, right? So we need to check if there's error. If that's the error, it means like we can't get the data from file, and that's like very severe. We can't really continue the program because we don't have data. So we just exit. We use the function from package called OS. We exit the program. Basically, we terminate the program, and it will cause the error. Because we found the error that's for maybe the file is we can't really read the file, and that's gonna exit. Or we can use like a panic. We can use panic to have a lock. So in here, this is just an example, and just an example that we exit the program and with the code. And so next, move on to another strategy. This one is called recovering and panic. So instead using a function called exit, we use panic here. It's like more gentle way to terminate program. So let's move on. Let's have a look at this example, recovering and panic. So we have a function. We start here. This we call this function my panic here. So it's gonna panic. This function gonna be called, and it will terminate the program. But before it terminate the program, it gonna call all deferred function. So deferred function here, we have a function called recover. Recover that actually can catch the signal. You can think of this. That's a signal that's sending from panic, and the message from panic. We actually can get the message here, and then we can print it out. So compared to this exit, that's like a hard termination, and the panic is like soft termination. We still can invoke the defer function from stack, and we are able to print out the message. So in order, that's the good way for us to track bugs, or we can see what's going on from the log. So that's the recovering and panic. And then next, move on for next one, for dealing with the error. So we can retry. We can have retry operation. So let me give you an example here. Okay, that's a little bit. So let's just retry operation here. So let's have a look at here. We have a retry operation. We say like retry, for instance, if you're gonna have a network request, so it might fail on first time, but if we can try like couple more times, it might gonna return with successful data. So here we have retry operation. We retry that for 5 times here. So it loops through the retry, max retry, and then for instance it's gonna have this is mock operation. You can think of that's a network request, and we try that 5 times until if that's a not error here, so we can return some data here. If that's an error, we gonna like a loop. We're gonna retry that for 5 times, and I think that's like a useful strategy, especially for network or for unstable environment. We can try to like a retry instead of just terminate the program straight away. Okay, let's move on. Let's comment that out. Okay, let's move on for next, the function values. As we know, the function in Go are the first class citizens. So it means that they can be like assigned to a variable, and they can pass as an argument, or they can return from another function. So give you an example here, function values. So we can assign the function to a variable here. We have defined a function called add, and take to param. and we can assign that to variable called op, and we can invoke that. Okay, that's the function values. And we also can be like, we can also be like, okay, for instance here, example here, that's the print line, that's a function. We can pass the function as a param here as well. Okay, let's move on to anonymous function. So, for anonymous function here, we don't need to name, we don't need to give a name to a function here. For instance, we have a function here. That's a function. Normally, we need to be like a function, and then we're gonna give it a name, and I give it a return type. But for anonymous function, we don't need actually need to give it a name. For this instance, it's a self-invoke anonymous function. So it will be called itself when we run the program. And for anonymous function, there's like another more important thing that I want to cover is called closure. So basically, the closure is that when we define a function, right, it's gonna capture the lexical scope. It's gonna capture the variable. So we're gonna give you an example here. So let me give you an example. That's the example of the normal function. As we can see, normal function, we define a normal function here, and we pass in the param. We add the param to 1. So basically, we're gonna pass in like count at 0. It's gonna plus 1. That's gonna be 1. So we call the function multiple times, so result gonna be 1. But if we do that with the anonymous function, we do that with anonymous function here. That's the anonymous function, and we're gonna assign that to a variable called increment and count. That input is different. The input is like 1, 2, 3. Let me just show you. As you can see, that's the input of 1, 2, 3. Cause like when we that's anonymous function, right? It actually, when we assign that to increment this variable, it actually that when we define the function, right? It can basically you can think that captured the lexical here, that scope, and the variable here. It basically they link. So here count here, that actually we don't get the value here, we get the like memory address. So when we call the first increment, so that's the result 1. But when we call that on second time, so before we call it second time, that count is not 0 anymore, because that's gonna turn 1 because we add here. Once we call the second one, so it add another 1 based on the previous one. So it's gonna be 2, and the third one, same thing. It's gonna add 1, because we don't pass the value here. So that's the like we have a memory address when we define the anonymous function. So that's like very it's very difficult to understand at beginning. Like when you get along with the programming language, like function programming language, you're gonna get used to that. Okay, so that's like that's the 2 important thing for anonymous functions. So let's move on for a variadic function. It means like the function you can pass in like multiple param before you can define it. For instance, we use like ellipses here to define a function. There's the num here, so you can pass as many functions as you like here before we can define that. Normally we define like we define a function like int, like that's num, okay, like num2, num3, num5, and we need to predefine. Normally, we need to predefine the param in order to pass the real values here. But we can use this this way to do, like we can pass the many param. We can use ellipses to deal with it, and if we pass the ellipsis, the function we're passing here is not individual anymore. It's like a slice, so we can loop through the slice, and then we can add it together, and that's the result of 15. Yeah, so this is a very useful one as well, because sometimes you just don't know like how many param you're gonna pass in. Okay, let's find out. Let's move on to the next one, and deferred function calls. And defer, like as if we don't normally see that from front end, like from JavaScript, but this is the new concept of the Go. So the defer function, that's going to be, for instance, if in a function, right, and we're gonna like normally we do that like one by one, like line 1, line 2, line 3, line 4. So if you see if there's a running a defer function here, basically it put that in a stack. So it put that in a stack, and you see another deferred. I put it on top of the stack, and I bring out the end. So the result gonna be result. If we're gonna run this, the result gonna be start and the end, and it's gonna be deferred to, because this is the last one in the stack, and the defer one. So let me just run that. As you can see, this is the log, the start, end, and the deferred. That's the like put on the stack, and the on top of the stack. And the main thing is defer function gonna be invoked before the function has returned. Like for this is very useful when we dealing with the like read file, like when we read the file, we need to open a string, right? And so before return, we need to make sure the file is closed, the stream is closed, and that's very useful in the network scenario as well. Like we're gonna open a network, and we make sure that everything's done, so we close the network connection. Okay, so that's the defer function. And then let's move on to panic. That's the billing method. So we have a panic. If you have a, like for instance, you running a program, you have a like expected error, an unexpected error. So normally for unexpected error, for instance like a memory leak or some hardware problem, hardware issues, we use the panic. We used panic to terminate the program. So the good reason, the good thing about panic is that if we use panic, right, it's not gonna terminate the program straight away. Instead, it gonna involve that whatever, if you have a deferred, it gonna call the deferred method from the stack. It's gonna call the deferred method from stack, and also also in the defer method we can have cover. That's the method that provided by Go. We can catch the problem from panic. So it's gonna be very helpful, very useful when we doing the debug. Okay, that's panic. And the recover, yeah, we just mentioned that recover. That's gonna catch the message from from panic. For instance, we have a here deferred. So normally if you have a like for exit, OS exit, right? And the program just stop here, and with the maybe with the code, but you don't know what actually is going on because that information is too little. You can't really tell. You can't really debug with the track. So the good thing of the panic is like when you see the panic, it gonna call all deferred function from the inner stack, and in the from the deferred function, we can have the method called cover. It get the message from panic. So if you think about if that's a link, it'll be very helpful for us to debug because we can see the link of the log. Okay, that's it for function in Go programming language. I hope you guys enjoyed this video. If you have any questions, please leave it on the comment. And I also gonna upload this code to GitHub so you guys can have a look. Okay, that's it for today. I'll see you guys on next time. Bye now.